Hello everyone. Today we are going to present you about linear regression. So first, machine learning is revolutionizing the way we analyze and project data, offering powerful tools to uncover patterns and make informed decisions. Among its many approaches, supervised learning stands out as a method where models are trained on historical data to predict outcome. In supervised learning, the goal is to establish a relationship between input, feature, like predictor, and a target variable, which can either be a category classification or a continuous value regression. One of the simplest and most widely used technique in supervised learning is linear regression. This method models the relationship between variables by fitting a straight line to the data, making it particularly effective for tasks where the relationship between predictor and the target is linear. Linear regression is not only easy to implement, but also provide interpretable results, making it a favorite in fields like marketing, sales, or finance. So we'll look at the regression problem. In marketing, the goal for companies sometimes is to understand which channel, like email, social media, offline promotion, and paid search, will lead to more sales. The challenge is to maximize return on investment by finding the right balance, as each channel has different level of effectiveness. The goal is to mathematically model how spending on this channel impact sales, allowing the company to predict outcome based on budget allocation, for example. To achieve this, we will use supervised learning, specifically linear regression, to analyze historical customer data and forecast future revenue. This approach will help optimize marketing decisions and identify high-value customers for targeted campaign. So our goal is to predict quantities using historical data in order to make data-driven marketing investments. Regression models are used to describe the relationship between a target variable, such as revenue, for example, and independent variable like advertising spend. This relationship can be a linear, where a straight line can model the connection between variables, or nonlinear, requiring a curve to better capture the trend. If the relationship is linear, a simple linear regression is sufficient for making prediction. However, if it's more complex, advanced models are needed. This helps businesses optimize their marketing decisions, such as determining how much to invest in an advertising channel to maximize revenue. So we look at linear regression. Linear regression is the relationship between the target or the outcome variable and predictor variable. And it is described using a straight line, just like I said. This method predicts the target by modeling its relationship with the predictors as a linear equation. So you can see the equation here. So in the equation, the y is the predicted value of the dependent variable, x1 represents the independent variable, b0 is where the line crosses the y-axis, and b1 is the coefficient for the independent variable. With multiple independent variables, the geometric interpretation becomes more complex, but we will see this later on. So let's look at the advantages of the linear regression. Linear regression offers several key advantages. It is simple to implement, quick to compute, and highly interpretable, making it accessible to non-technical stakeholders, for example. The model's coefficient clearly shows the impact of each predictor on the target variable, making it effective for understanding relationship in data. It performs well with linear relationship, require minimal parameter training, and provide reasonably accurate prediction in case where the relationships are straightforward. However, linear regression also has notable limitations. It is restricted to linear relationship, which make it unsuitable for capturing more complex case, nonlinear interaction in data. Additionally, it is sensitive to outlier, which can distort the model and reduce accuracy. Linear regression also assumes independent effect of predictor, making it ineffective when variables interact in complex way. Moreover, it can suffer from bias and high variance if its assumptions are met or if data is limited. While effective for simple datasets, linear regression is often outperformed by more advanced models.
Est-ce qu'on m'entend bien avant de commencer?
Yes. Oui.
Ok. So,
Oui.
d'accord. Um, So the next part is how to use feature engineering and data cleaning for regression. In this section, we will see how to use to use feature engineering and data cleaning for regression in digital marketing. Raw data obtained directly from the source is often not ready for modeling. For feature engineering consists of transforming this data into relevant predictive variables. After creating features and data cleaning is necessary to ensure the quality of the models, including the management of missing data and outliers. This process must be technically and commercially relevant to ensure decision useful models. Um, So feature transformation and creation process. To perform a regression analysis, the raw data, often in the form of customers' transactions, needs to be transformed into meaningful features that can act as predictors. As shown in in the diagram, raw data from various sources undergoes a feature creation process, capturing aspects that are potentially predictive of the target outcome. Features represent key aspects of the data that might influence the predicted variable. If the goal is to forecast a customer's future spending, useful features could include the total number of past purchases, the cumulative spending amount, or the time since the last order. Each of these features is designed to encapsulate customer behavior patterns that may relate closely to future spending. This transformation phase is essential for building a model that can that accurately capture the capture trends and relationships within the data settings, the foundation for effective predictive analytics. The next part is data cleaning and preparation. During features creation, it's common to identify issues within the data that require cleaning to ensure quality and reliability. Effective data cleaning can significantly enhance the accuracy of predictive models. Handling missing data, missing values can disrupt the analysis and lead to inaccurate predictions. The simplest approach to managing missing data is to remove data points with missing values when it's feasible. However, in cases where removal is not ideal, a common solution is to input missing values, typically filling them with the mean or median of other data points. Then addressing outliers. Outliers are values that fall significantly outside the normal range of a variable, potentially skewing the result of a regression model. As shown in the histogram, most values for the variable x lie within the 0 to 9 range, but there is an outlier far above this range. Outliers might result from data errors or represent valid but extreme cases. Strategies for handling outliers include removing them if they are likely errors or adjusting them to minimize their influence, depending on the context of an analysis needs. By addressing these data quality issues, we set the stage for a more reliable feature engineering process, ultimately enhancing the model's predictive power. So the next part is creating feature for customer revenue prediction with the Aswa example, which is a high fashion retailer aims to identify high-value customers who are likely to bring in higher revenue. To achieve this, we'll predict customer revenue for 2020 based on purchases data from 2019. If successful, this model can help Asbra target valuable customers with tailored marketing strategies. The datasets and features. The datasets include transaction records which fields such as first customer ID is the unique customer identifier, the quantity, unit purchases per transaction, the invoice date, date of purchase, and unit price, cost per item. Our goal is to engineer a feature based on 2019 data that help predict total spend in 2020, making revenue 2020 the target variable. The different step of the feature engineering. The first is to calculate revenue per transaction by multiplying quantity and unit price. We derive the revenue for each transactions, providing insight into spending per purchase. The second step is to aggregate data by invoice. Transactions are grouped by invoice to create one row per purchase, simplifying the analysis. And the last step is to create key features. As you can see, the revenue 2019, total revenue for 2019, representing past spending behavior, day since first purchase and day since last purchase, the time since the first and last purchase in 2019, showing recency and duration of engagement. The number of purchases is the total purchases in 2019, indicating engagement level. And finally, the AVG, or the cost, average transaction value, reflecting spending habits. These features capture essential aspects of customer behavior, spending, recency, frequency, and order value, forming the basis of our model to predict revenue 2020. This structured dataset, as it's shown in this figure, allows Azra to identify potential high-value customers for targeted marketing. To conclude, good feature engineering and effective data cleaning are crucial to maximize the performance of regression models. These steps helps to improve the accuracy of predictions, avoid bias, and obtain more robust and interpretable models. The important key point to remember are feature engineering, which transforms raw data into useful variables to predict a target variable. Data cleaning eliminates errors, missing data, and outliers to ensure the quality of the feature. Both processes are essential to improve the accuracy of the model and make the prediction more reliable.
After we talk about the preparing data for modeling customer revenue using a linear regression. Once you have created your feature of interest, the next step is the assess tools features. A commonly followed sequence is a follow. First, you should perform a data consistency check to ensure that the value align with expectation. Plotting histogram for each value can help vary their distribution and uncover potential issues, such as unexpected value. There are two types: missing data, we delete them or replace them with average median value, and outliers. These are data that differ strongly from the normal. They can distort the model. The next step is to examine the relationship between your features and the outcome of interest. This can be done in the following two parts and two ways: creating scatter plots, most effective means of assessing relationships, and assessing correlation, another quick and effective method for assessing a relationship. I remind you that correlation is a quantification of the linear association between two variables. Correlation can be positive, meaning that when one variable increasing, the other also increasing. For example, you will expect sales to have a positive correlation while marketing expands. A correlation can also be negative, meaning that when one variable increases in value, the other decreases. For instance, you will expect an unemployed customer to purchase favor luxury car. The correlation value quantifies the association between variables as a single number. For example, in this model, in figure 1 and 7, we can see that the linear relationships are perfect, therefore with a value of 1. Figure 1 has a correlation of +1 because when x increase, y increase. The opposite is true for figure 7, which has a correlation of -1. For the other figure, the more imperfect the linear relationship are, the points are stacked The closer the correlation gets value to 0. If x increases with y, the correlation value will be positive, and conversely, it will be negative. As an example, we can follow the result for the previous exercise. This time, we want to see the correlation between the dependent variable and the independent variable. This will help us understand how different features related to purchase history affect the customer's future income, as well evaluated whether the association in the data make commercial sense. We can calculate the correlation value using P2 on the data frame in the formula curve method. This allows us to quickly identify the strongest or weakest relationship between the variable and the target. To beginning, after reporting the data, we will create a scatter plot with it. We can see that even though there isn't a very strong correlation between them, in general, higher revenue case are observed for customers with longer tenure. Next, using the pair plot function, we can create a scatter plot like this. And the result plot is as follows in the right. Yeah, we could take the time to analyze all data, but we will focus on the role of our variable. The strongest correlation in the 2019. Visually, the strongest correlation with the function curve is like this. We need to look at the last row. The strongest correlation is with revenue 2019. This means that the higher clients revenue 2019, the higher the expected revenue 2020 should be. In conclusion, we can say that there are moderate correlation indicating that other factors also influence revenue 2020 for the company, suggest that there is some continuity in customer purchasing behavior or overall company performance for year to year. There are careful customer loyalty or market consistency. ARSA could identify the customer who generate the highest revenue in 2019 to target marketing effort in 2020, as it is moderately likely that they will remain profitable customer.
So now, in this part, I will go deeper into the explanation of linear regression by re-explaining first the complex equation. Then we will try to understand the model and interpret concretely the results. So as my classmates said, the model of linear regression is a type of analysis to explain the relation between two variables, y, dependent variable that we want to predict, which is influenced by x, the independent variables, and we call them predictors. So I use the plural because you have several variables or factors that impact the final results, and this is what we see in the real life. Each variable has a coefficient, which is illustrated by bi, so it's kind of the weight of each factors. And we finally have B0, it's the intercept, so the value of y when x equals 0. So, for example, on the figure we see, je peux switcher, s'il te plaît? Thank you. So, in the figure we see the intercept is equal to 5 because the line crosses y in 5. To be more clear, this figure illustrates the equation, and we used Python to generate it. So now what this figure really means, the blue points are simply indicate the different values of x, and the red line is the line of best fit, so it minimizes the difference between itself and the blue points. So basically it's the line that gets as close as possible to all the data points on average. And there is number because we encoded all qualitative information, because obviously in the real life, we're not talking with numbers, but data are proofs. The good things with this model is that it's easy to interpret. You just have to look on the coefficients and you can easily predict how much y will change. But there is a limitation because in the real world, the relationships are not linear. So it gives you something like that we will see right here. But with the advanced technologies, we can fix that and make it linear. In this case, we use Python and introduce to the algorithm the command linear regression. The thing with Python, it's that it's a supervised machine learning that makes things easier. I mean that there is an approach that you can use in Python, which is train test, where we train the model with data, we teach it how to process, and then we give to it new and unseen data to make sure it got the process and not only memorize it. So this approach accelerates the analysis and simplify our assignments because we only have to teach to the machine how to process. The machine learns and reproduces what it learns for all data we want. And finally, it predicts the potential solutions. So now we tried this for the following problem. Help the company Azra to predict the future revenue for a customer based on past transactions. So here, the y-axis will be future revenue, and the x-axis will be the past transactions. We imported the transactions database file into the algorithm to teach the machine how to process it. And we give it data outside our data set to see how it will manage. And we finally got this figure here. So the figure compares the predicted results and the true values. We see that points are scattered far from the line, indicating that the model struggled to predict revenues accurately. So to give you a concrete interpretation, the red point refers to a customer. So we can say that the model predicts for this customer to bring $2,800 for the company. However, the true value that this customer brought is $3,100. And it's logical because there is not such a big difference between the two values, and the point is not far from the line. So here's the full equation. We can explain that for revenue 2019, the coefficient means that if a customer spent 1 unit more in 2019, their predicted revenue in 2020 increases. And this makes sense because customers who spent more in the past are likely to spend more in the future. For days since last purchase, the coefficient means the model predicts higher revenue as more time passes since the last purchase. But this is not really logic because customers who buy more recently usually spend more and not the opposite. For a number of purchases, the coefficient shows that the more you buy, the higher your revenue is, and that's logical. And finally, for average order cost, the coefficient means higher spending per order slightly reduces predicted revenue, which doesn't seem logical and might be caused by issues with the model. So despite this, we calculated the correlation coefficient between true values and prediction. So we calculated the correlation coefficient between true values and predictions, and we got 0.613. This means there is a fairly strong relationship between both axes. It's not perfect, but it shows that the model has learned from some patterns from the data. So now the last issue presented to us was this one. So Azra wants to choose the right location for upcoming stores by building a model that predicts revenue, that predicts stores revenue based on information about store locations. We imported the information to help the machine works better, and here is what it gave us. So in this case, the points refers to the different locations, and the numbers are the potential revenue that this location will generate to the store. We can clearly see that the model worked very well because the points are very close to the line. It means that the machine had accurate predictions regarding the true value. And this conclusion is confirmed by the correlation, that is 0.91. So the more the result is close to 1, the best it is. Finally, the explanation we can give is linked to the quality of data sets. Indeed, the more a data set is including better features, more data, more precise and pre-processing improvement, the more the machine will learn and give accurate results. So we saw that the regressive linear model is a very good tool to help managers to take decisions and predict through a data set. But note that you can have some errors, so some differences on your model, like we saw on the first exercise. There is other models that fill the gaps where a linear regression failed to evaluate, but you will see those in the next presentations. So thank you.